Hi everyone. Today we are going to see the concept of controllability and observability. See, if the initial it is given as x of t naught, okay, and if you want to get x of tf by using a control function u of t, that means this control function, okay, it is going to transform initial state x of t naught to the final state x of tf is called as the controllability. I repeat again, the control function u of t is going to transform or control the initial state x of t naught to the final state x of tf is called as the controllability. The controllability formula or matrix form, it is given as b ab a square b and so on a power n minus 1 into b, where n is the size of the matrix, and if this matrix is not equals to 0, then it is a non-singular matrix and it is controllable. And what do you mean by this? Observability means, see, we are going to have some output, right? So if this output is carried out for see the measurements for this output we are going to do for some interval, say some 0 to tp, then you are going to observe all these different measurements of output. Okay, so by observing that you are going to determine the state of the system. You are observing the system, that is nothing but the observability. So it is given by q naught is equals to c transpose a transpose c transpose a transpose square c transpose and so on a transpose whole power n minus 1 into c transpose. The same way this is total matrix, and if this is not equal to 0, this is a non-singular matrix and the system is observable. Let us have the clarity of this controllability and observability how to calculate by solving one problem. Okay, so given the problem, find the controllability and observability if the system is characterized by transfer function. One thing you should observe, whatever he gives, at last your conclusion is you should have one matrix. See here in this problem he gave the transfer function, but where to bring this A, B, C matrix? We know, we seen in the previous videos. What is that? State equation is x dot is equals to ax plus bu, and y is equals to, y is given by cx plus du. In this format you should get the matrix, but here he gave the transfer function, same method. From this transfer function do the cross multiplication, okay, 2 into u of s, so taking inverse Laplace transform, so it is cube, so you are going to get 3 dots for y into t, plus 6 into this is s square, so 2 dots into t, plus s y dot of t plus 6 y of t is 2 into u of t. And now see, it is 3 dots, right? S cube, we wrote 3 dots, so you are going to have 3 variables. Here n is 3, so you are going to have 3 variables, so name them as x1, x2 and x3. So let us assume y is equals to, so you can write here y or y of t, no problem, y 3 dots plus 6, y 2 dots plus 11, y dot, like that also you can write. And see, y of t is x1 you should assume, so y dot of t x1 dot x2, y double dot of t x1 double dot x2 dot is x3, and here again if you keep 3 dots, for x1 3 dots, x2 2 dots, and you are going to get x3 dot. No need to write here x1, but just I mentioned here, no, not necessary to write also, no problem. Okay, see here same in the previous videos we explained. 3 variables means the matrix you should get in the form of x1 dot, x2 dot and x3 dot. See here, anyway we have x1 dot as x2, x2 dot as x3, but we don't have x3 dot in terms of x1, x2, x3. That's why we are substituting in this equation. Y triple dot of t is x3 dot plus 6 into y double dot of t means you have x1 double dot, x2 dot, x3. Which term to substitute? The term without the dots, that is x3. Why? Because we want x3 dot in terms of x1, x2 and x3. Okay, so that's why I am substituting in place of y double dot of t x3, right? 11 y dot of t, not no dot term is x2, plus 6 What is y? x1 is equals to 2u. So x3 dot is this. So from this we are going to write the matrix in terms of x1 dot, x2 dot and x3 dot. So from this I wrote the matrix x1 dot, x2 dot and x3 dot. So x1 dot is x2. So only x2 term is 1, remaining x1, x3 are 0. x2 dot, x3 is on remaining 0. So x3 dot, x1, x2, x3 minus 6 minus 11 minus 6 into this plus what is b? For x1 no u 0. For x2 no u 0. For x3 we have one term as u. This is 2 into u. Okay. So output equation y is equals to, so only x1 term is there. So only 1, 0 and x1, x2, x3. From this matrix now we have, this is in the form of x dot is equals to ax plus bu. So this is A matrix, this is B matrix and this is in the form of y is equals to cx plus du. This is d term 0. So C matrix is 1, 0, 0. That you should mention here. That is A is given as this, B this and C this. Now you should come to the formula of controllability matrix formula. QC is equals to B A B A square B A power n minus 1. See what the matrix we got here? 3 by 3 matrix. N is 3, right? So if you substitute 3, A power 3 minus 1 is A square. So how many terms you should write? B A B A square B. So determine AB so that you can easily determine A into AB easily. Don't go for A square into B. Why? Because again you should calculate AB. AB then A into AB. It's very easy process. See here matrix multiplication row into column. 0 into 0 plus 1 into 0 plus 0 into 2. Right? Row into column. If you have another column here, then you are going to get another row term here. But here you have only one column and one row, right? So that's why next, this row, this column. 0 into 0 plus 0 into 0 plus 1 into 2. This is not there. So if you calculate this, all 0 is there in 0. 0 plus 0 plus 2, 2. Next again this minus 6 into 0 plus minus 11 into 0 plus minus 6 into 2. You are going to get minus 12. So represent, this is a matrix, right? 0 to minus 12. And A into AB, same way we did. Row into column and row into column. 0 into 0. 1 into 2, 2. So that's why I wrote here 2. This is 0. This is 0 into 0, 0. 0 into 0, 0. Plus 1 into minus 12 is minus 12. And this into this, minus 6 into 0, 0. Minus 11 into 2 is minus 22. Minus 22. Plus minus 6 into minus 12 is 12 6 are 72. Plus 72 minus 22 is plus 50. And I multiplied with 2. 2 6 are 2 1 are 2 6 are 2 25 are. No need. If you write directly also, no problem. Okay. So total QC matrix is, what is B matrix? 0 0 2, 0 0 2. And what is AB? AB we have 0 2 minus 12. And then A square B. What is A square B? We got 1 minus 6 25. That you mention in this matrix. And then you calculate QC. So it is 0. QC is anyway not equal to 0. So if it is not equal to 0, you say it as a non-singular matrix and it is controllable. And observability, the same formula. Q naught is C transpose, A transpose, C transpose and A transpose square, C transpose. Why? Because already we calculated n minus 1. 3 minus 1 is 2. Okay. So AT square, AT whole square into CT. So C transpose, the transpose means change rows into columns and columns into rows. Okay. And A transpose, and you just multiply A transpose into C transpose, you are going to get this matrix, row into column. And this A transpose into A transpose C transpose means anyway this is the A transpose C transpose and this is A transpose matrix. So row into column, you are going to get this matrix. So therefore Q naught is C transpose is 1 0 0, A transpose C transpose is 0 0 1 and A transpose square C transpose is 0 0 1. Here see A transpose C transpose row into column. 0 into 1 0, 0 into 0 0, minus 6 into 0 0. Okay. So like that I did it and I got this, and again I got Q naught not equal to 0. Okay. So it is a non-singular matrix and it is observable. So it is observable. So the system is both controllable as well as observable system. Thank you.